Cool. All right, so we can get started with class. Oops, let's get rid of that. So last week we went over arrays in Java, and we talked about how arrays is a way to organize basically a bunch of variables together. It's a way of storing multiple pieces of information. It's also something called a data structure, if you've heard of that, because it's a way of structuring data. And specifically, what an array does is it just organizes these variables into a list. And so you have a first thing in the list, you have a second thing in the list, and the list has a certain size. I have a few review questions just to go over some of the properties of arrays in Java. And so we can actually just go over them one by one. So the first question is true or false. Java arrays can only contain one type of object. And so if anyone wants to volunteer or maybe put into chat, let's do these in chat actually. So everyone, if you could take a moment, just put true or false, T or F. Is it true that arrays can only contain one type of object? The opposite to this would be that you could have an array that contains an integer and a double. Is that possible? So Kaden says true, but let's get a couple more answers. I want to see if people agree or disagree with that. Answer in chat. All right. Well, all right. Maybe I'll call on people for the next question, but for this one, the answer, you're correct, Kaden, is true. In Java, arrays are declared with a certain type. So you make an integer array, or you make a double array, or you make a string array, whatever. But when you make an array, you declare its type. And once you declare a type, you can only put things of that type into the array. And so you can't like mix and match. The answer to this is true. The second question, true or false again. Java arrays automatically resize when you add more and more elements. So we talked about how an array is kind of like a list where you can put things into it. And I'm asking, is it true or false that it will expand when you put more and more things into it? For this, maybe I'll call on someone. Ethan, can you give me true or false?
Right.
I think false. I mean, yeah, false.
Yeah, you're correct. It is false. And so this is where Java may differ from other languages, but in Java, when you make an array, you make an array of a certain size and it's fixed. So once you create an array, it's always the same size. It never shrinks, it never expands. If you end up needing more spots, well, too bad. You just have to make a new array. So the answer to this one is false. And finally, the last question is about indexing into arrays. So it's a list, you need some way of accessing the different elements inside the list. And so with that, we use indexing. So I have a quick question. If I have an array of length 5, which basically means it contains 5 elements, what is the index of the first element and what is the index of the last element? So all right. I see multiple answers in chat now, which is great. And yeah, the correct answer is 04. Yeah, thank you everyone for answering. So the reason for this, again, indexing is just like with strings. So the first thing has index 0. The second thing has index 1, so on, so on, so on. And so the trick kind of is that the last element of the array is always 1 less than the length. So if the length is 5, then the last element has index 4. And that's just because when we're indexing, we start at 0. So everything's kind of like off by 1. Because when we talk about length, that's a case where we do start counting at 1, right? If we talk about the length of an array, we count 1, 2, 3 spots, and it's length 3. Or if it's length 5, we count 1, 2, 3, 4, 5. But for indexing, we don't start at 1, we start at 0. So everything's shifted over, and you have to remember that. So with this, we can move on to the homework from last week. And it was a little bit of a different format. I gave you kind of a skeleton to fill out. I told you where to put code. And so we can look at that together, and maybe I'll call on some people to fill in the lines for me. Pretty much everyone that I saw who submitted the homework, it looked good. Seemed like people knew what they were doing, which I'm very happy to see. But I still want to go over it for everyone. All right, so if I open up Eclipse and I want to make a new class, hopefully this is all familiar now. I remember back at the beginning, Eclipse was very intimidating with all the buttons and all the options, but hopefully it's gotten familiar now. That was class 6 homework solution. Oops, I misspelled it, but that's fine. I'll fix that later. So I'm gonna take the instructions. I already have it here, paste into here. All right, so if we look at what was posted to Google Classroom, I put all the instructions in comments. Let's see if I can, there we go. So what your input was an array. And so I want to take a moment to look at this. This is, I put in the comments, a way of creating an array that we didn't go over in class, but this is a way of creating an array where you want to create it and fill in the values at the same time. So if you have an array and you already know what it's supposed to contain, you can create it like this. And the syntax, the grammar, the way you do it is the left-hand side is nothing different. You're still creating it into array, and we're just calling it input. But on the right-hand side, instead of that new stuff and everything, you just put the squiggly braces, the curly braces, and then the values of the elements in your array separated by commas. So here it's containing 1, 2, 3, 4, 5. Right? And so the first step of this homework was to actually create another array. And this time, I told you wanted an array of size 2, and you're going to create it slightly differently than this one in line 7. So maybe someone, Megan, can you give me the line that I'm supposed to put here to create the array of size 2? Maybe put it into chat, or you can tell me and I can type it out. But how do I make an array of size 2? And maybe I should have specified an int array. So I'll start it out. So what do I put here? Make an int output, int array output equals new int array of size 2. Yeah, that looks great. So the things to remember, these square braces, let me zoom in a little bit. These square braces represent an array. So whenever you see these square braces, think I'm dealing with an array. So here, the type of our variable is an int array. The name of it is output. And on the right-hand side, we're creating a new variable. So we're using the new keyword. And what are we creating? We're creating a new int array of size 2, right? And so that's what this line means. Again, a lot of times when we're creating new variables, you'll want to use this new keyword. The reason why we haven't seen it too much before is because we were dealing with things called primitive types, as I was mentioning. So primitive types like integers, doubles, booleans, characters, these are all primitive types. They don't require the new keyword. Strings is kind of a weird case, and I'm sorry about that. So strings are not a primitive data type. And so that's why you can use the new keyword to create strings. If you remember, an example of how to create a string was like string s equals new string, and it'd be like hello, something like this. This is another way you can create a string. And you can see it kind of is very similar to how you create an array, right? The data type, the name of the variable, you have new, and then you have the data type again. And the difference is here you're using square brackets because it's an array, and here you're using parentheses. And then inside you put kind of information to make this new data type. For a string, you have to tell it what string it is. For an array, you have to tell it how big it is. All right. Yeah. So new is very important for creating new variables. All right. So the next part of the homework was to access and store values into arrays. Shouldn't be too hard. Where the first part of it is accessing the first element of the array. And then we want to store the value into the first spot of the output array. And so remember, just like with normal variables, so for example, if you had a variable called x, and you want to store a value into that, you do something like this. You have the place to store on the left-hand side and the value to store on the right-hand side. So if we kind of imagine this for arrays, where do we want to store this value? We want to store the value into the first spot of our output array. And so remember, the first spot means index 0. So output 0 is where we want to store the value. And then on the right-hand side is the value itself. So what do we want? We want the first element of the input array. And so first spot, first element means index 0. So we do something like this. All right. So that's the next part of the homework. And then step 4 is kind of doing a very similar thing, but this time we want to take the last element of our input array. Here it's going to be this element, and we want to put it into the second spot of the output. So really what we're doing here is we're creating a new array where the new array contains the first and last elements of our original array. And so, I don't know, Ethan, or I already called on you, Ethan. So maybe Tushar, if you could help me, what should I put on step 4? How do I get the last element and store it into the second spot of the output array?
Output 0 equals input 5 or input 4.
Close. So I'm going to type that out. So I think there's one thing slightly off here, and if I look at the instructions, remember I want you to store it into the second spot of the output.
Oh, sorry, yeah, 1. Sorry.
Yes. Yes. And so just a follow-up question. This is great, but can you tell me how you got this number 4 here?
So 4 would be the last. So if there's 5 spots in the array, 4 would be like basically the last spot.
Yeah, great. So our input array has length 5, and we want the last element, so it's index 4. And so this works. And the last step was just to print it out. So system.out.print line. And I said you can't just really print out the array by itself like this. And that's because if you run it, you'll see what goes on here. You'll see this. And if you ran into this previously, this is what happens if you try to print out an array directly. And what this is actually saying is this is the memory address of the array. And this is not what we want when we want to quote unquote print out an array. And so you can just print out the elements directly like this. So print out the first and the second elements. And here we got 1 and 5, which is what we wanted. And so in chat, I see a suggestion from Caden, length -1. And so that's kind of a follow-up to what I wanted to do. Whenever we're programming, we want to try to avoid hard coding values. And here we have a couple hard coded values. We have 2 here, we have 0s here, and a 1 and a 4 here. Some of these are fine, some of these are less fine. So like this 2 is fine because we always want the array of size 2. That was the instructions. And like this 0, this 1 is also fine because again, the output is always going to be an array of size 2. You're always going to want the first element and the second element. The one that's problematic is this 4 here. And that's because this 4, as Tushar explained, was because the input array was length 5. And so the last index is 1 less than 5, 4. The problem is what happens if the input changes, right? What if my input gets a couple more elements, right? Then if we run our code again, well, we run out of luck because it still says 1, 5, because this number was hard-coded. What we want to do instead is to turn this kind of into a variable. And how can we get this as a variable? Well, if you think about where this number comes from, it depends on the length of our input. And so as Caden put, we can just get the length of the array, which is input.length. And this is something I also want you guys to remember. Finding the length of arrays is always very important. And we don't want the element at that index because that's out of bounds. We want 1 less than that. And this goes back to the warm-up questions I was talking about. And so here, now it will work for any size input. So if we have more elements, it works. If we have less elements, it also works. Right. So I would say this is a slightly better solution. Although if you did 4 there, that's also fine. It works for the input that I gave. But it's always good to think about what might be different, what can change, and how you can adapt to that change. The last thing is not super important, but it can be nice. Let's see, my Zoom disappeared for a second. I think. So you can do something like this. This is just a tip. So there is this thing called arrays.toString, and you can give it your array. And this will actually print out your array how you want it. So it'll actually format it nicely for you. It'll put the comma, it'll put the square brackets. And yes, I will put this into chat for you. So one thing to watch out for this though, is this requires something that to be imported. And I'm not going to go over this too much because it's kind of out of scope for now. And that's why this is just a tip. If you want to use it, you don't have to. I'm not going to require you to remember this, but you have to do something called import java.util.arrays. Eclipse is smart. So Eclipse, if you paste this in or if you type this out, it will automatically import for you. So if you notice, I didn't type this. This was put in for me. Right, I can even show it again. So there's nothing at the top of my screen. If I do print is .toString, and I can print out args, you'll notice while I was typing, this showed up again automatically. And so that's something that Eclipse as an IDE will do for you. And it's nice just wanted to put this out in case anyone was interested. But that's it for the homework and review from last week. Does anyone have any questions about arrays? Anything from the homework, anything from class? Happy to answer anything people might have. Right. All right, so I want to mention one thing for arrays, and then the rest of today's class will be on a new topic, which will be about conditional statements. And I think it's going to be kind of an interesting class because it allows your code to do more than just the basic functions that we've been doing up until this point. But the first thing before that I want to talk about is with arrays. So far, all we've done is create like integer arrays or string arrays or just arrays of a data type that we've seen before. But you can actually do something where you nest arrays inside of other arrays. So you can have an array of arrays. And what that does is it makes kind of, if you imagine a normal array as like a 1D list, right? It's like one element, then a second element, then a third element, kind of in a line, right? A nested arrays would just be like a 2D grid. So you have an array, but each thing in the array is now another array. And you can imagine it as like the first one goes horizontally, and each spot in that array is another one that goes vertically. And so that makes like a grid of arrays. And so just a really quick demo. This is kind of a more advanced thing with arrays. So don't worry if it's a little bit confusing, but I'll try to make it as clear as I can. Let me just make a new file. The first step is I want to print out this, I want to create a 2D array. And so does anyone want to take a guess at how we do this? Really what I'm looking for is whenever we're, well, I'll just make a 1D array for now. So I'm not going to worry about the right-hand side, but here's how we make a 1D array. I think Lucas, earlier you had your hand raised. Did you want to take a guess?
You just put two square brackets in each other.
Yeah, that's actually correct. So
Oh, no way. Shit.
all right, off your language, but yeah, so it's correct. And so there's actually a very logical explanation of why this is correct, but I'm gonna make this, I'll call this array 2D. So it actually should make a lot of sense. So if we think back again to the 1D array example, what does this mean? It's an array of integers, right? It's something that contains a bunch of integers, right? And so if we break down this line, what does this mean? Well, what is the type of array 2D? Well, it's an array of integer arrays, right? So here, it's an array of integers. On the second line, it's an array of integer arrays. Right? So you can think of it as almost like a grouping, right? So the square brackets always means array. So you can kind of work backwards. What is this? It's an array. What is it an array of? It's an array of integer arrays. So that's how you get the nesting, right? And so I'm going to take out the parentheses. They're not actually there, but you can kind of imagine them. You can even imagine, so the nesting doesn't stop there. You can nest even further, right? You can create a 3D array by doing more square brackets. You can go as far as you want, right? you'll basically never need an array of this dimension, but you can make it if you want. Typically, you're going to deal with 2D arrays or maybe 3D arrays, but most of the time it's 1D or 2D. Then on the right-hand side, I'll just give it. So with a normal array, you do something like new int array of size 5, right? This time, you would say new int, and then just like before, you have 2 square brackets, and then you have 2 dimensions. So you have the first dimension, let's say 3, 4. And so what this is saying is you're creating a 2D array. Oh, something's wrong here. Oh, I forgot the equals sign. That's wrong. So you're making an integer array that has 3 spots. And then each element in that spot is another array with 4 spots. So if you imagine this as a 2D grid, it's kind of taller than it is wide, if that makes sense. So you have 3 spots, and then in each of those 3 spots, you have an array of size 4. And so accessing and storing is what I'll go over now. It's very similar to a 1D array. It's just, again, you go an extra level, an extra dimension. Oh, okay, so Caden, I see you have 1, 2, 3, 4, 5, 6, 7. I'm not sure, but I just want to clarify. This is different than having like a 3, an array of length 3 and then an array of length 4. Maybe someone can tell me how many. So this creates an array with 5 spots for me to put values into, right? It's an array of length 5. Here I'm making a 2D array. How many spots do I have access to? How many places can I store values? And so in chat, I see a couple of 12s. 12 is correct. You multiply because again, it's like a full grid of arrays. It's 3 times 4. You have 12 values, and I'll show you a little bit more. So accessing. So I'm always gonna relate this back to the 1-dimensional case because that's the easier one to understand. And we'll see how the 2-dimensional case kind of builds upon it. So with a 1-dimensional case, let's look at accessing, right? So you'd say like int x equals ARR 0, for example. So here we're taking whatever's in the first spot of our array and we're storing it into an integer variable, right? And that's just because ARR, this variable, is a 1-dimensional array. It's an array of integers. So once you give it an index, it will give you an integer, right? Because that's what the array contains. On the other hand, with a 2-dimensional array, well, let's just kind of do it backwards. I'm going to do the right-hand side first. So if I do ARR 2D and I give it 0, what kind of variable is this going to be? Right? What is y? Is it an integer?
Doesn't it depend on what you put in the array?
So I'm not looking for the value of it. I'm looking for the type of this variable, which does not really depend on what you put inside. With this line, you know everything you need to answer this question. So Caden says int, and so unfortunately that's not correct. You're missing something. It's close. It's not an integer. It's not a new int. Any other guesses? Int array. Yeah. So Caden got it right. It's an integer array. And again, the reason for this is, well, let's look back at the 1-dimensional case. In a 1-dimensional case, you have an array that stores integers. So once you give it an index, you get an integer out of it. It stores integers. So what do you get out? You get out an integer. A 2-dimensional array, well, what does the outer array store? It's an array of arrays. It stores more arrays. This is where the nesting comes in. You have arrays inside of arrays. And so really this two-dimensional array, when you give it one index, you get an array out of it, right? Because this array 2D has 3 arrays of length 4. I'll say that slowly. This variable, ARR2D, is an array of length 3, and each of those elements is another array of length 4. So here, when we're accessing ARR2D0, what we get out is an array. This array Y has a length 4, and I can do system.out. I'll use the trick as before. So if we do this, you'll notice that I get an array of length 4. There's 4 spots. And maybe I can even do it here.
Wait, how are there 4 spots?
All right, I'll go over that. So unfortunately, this is not correct, but deep 2 string. So that's what I have to do. So hopefully this makes a little bit more sense. So I'm going to comment this out for now, and I'll answer why it's 4 spots. Here I'm printing out ARR2D. And so you can see there's these square brackets, which means it's a list. It's an array. Inside the array, there's more arrays. So here's an array of size 4. Here's an array of size 4. Here's an array of size 4. Notice there's 3 of them. That's where the 3 and the 4 come in, right? So if I change this to 8, for example, then you'll see the arrays inside get a lot longer, right? I still have 3 of them, but now they contain 8 spots, right? Let's change this back to 4. And so when we say ARR2D0, well, we have this ARR2D. What is at the first index? Well, it's an array of size 4, right? It's an array of arrays, right? And this is again why this ARR2D has 12 spots, because there's 3 times 4 spots, 12. Tushar, did that help a little bit with seeing how?
Yeah. Thank you.
Yeah, no problem. All right, and so usually when you work with 2D arrays, you won't do stuff like this. You won't just access with 1 index. Typically, you'll index with, you'll use 2 indices, so like this. And so if you, or 6 doesn't work. Let's do 2. And so here, if we think about what we're doing is, here we're taking our 2D array, we're getting the first thing in it, which happens to be another array. And then we're getting the third element in there, which is this 0. Right? And then now we finally have an integer again. And if we again compare this, here we only have to give 1 index because it's a 1-dimensional array. Here it's a 2-dimensional index, so you have to give 2 indices. And then you get an integer at the end. So this is accessing, and then storing into this is very similar. So we can do like ARR2D. Let's say 0, 1 equals 6. Right. And then I'm going to print out the array again. Right. And so you notice this is what it was originally. And then here's where I printed out again. And you notice which one did it change? Well, I first go into the first array, which is this one. And then I access the second spot and I store a 6 into it, right? And that's why the 6 shows up. So maybe a really quick question. If I wanted to set this value to an 8, can anyone give me the line of code that would do that? Again, I want to take this spot and store an 8 into it. You want something just like this. But now you have blanks. Store an 8. So can anyone tell me what goes in these spots if I want to update this? Kaden says 3-3. Does anyone agree, disagree? Anyone want to back Kaden up? No one wants to say anything, but I'm going to say not quite. I see a direct message that's also not quite right. I think I understand where both of these answers come from, but remember how these indices work, right? So I see a lot of direct messages. And finally, I see one that's correct. So the answer was 2-2. And let's see why the answer is that. So just to show you that it is the answer, I'm gonna do that. I'm gonna print out the array again. And we can see that that value turned to an 8. And the reason why is because you have to think about how the indexing works again. The first index tells you which of these 3 arrays you want to work with, right? There's 3 arrays. You need to tell Java which one are you interested in. Well, we're interested in this one, right? The third array. The problem is, again, be careful with your indexing. Indexes start at 0. And so this is actually the array at index 2. And so that's where this 2 comes from. Then once we know that we want to work with this array, now the question is, well, this array contains 4 things. Which one of these 4 are you interested in? Well, again, we want this one. And what index is that? 0, 1, 2. And so that's why it's 2-2. And I think that's why the first answer that we saw was 3-3. Maybe it was the third array, the third value. But again, indexes start at 0. So -1 on all that. 2-2 is the answer. Right. So that's an example of arrays. Any questions on this? I know it's a little bit complicated. I'm gonna copy this shortcut into chat again. This is just how you print out a 2D array to make it look like this. This is definitely a more advanced topic. This is something that you don't really work a lot with until like even in AP computer science, this is still usually a tricky concept for most students. So don't worry about it being a little bit fuzzy now, but hopefully it makes a little bit of sense why when you're creating a 2D array, you give 2 square brackets. And whenever you're working with it, you typically give 2 index values compared to a 1-dimensional array where you have 1 set of square brackets and you only give 1 index. It really is just like 1 level higher. So with that, last call for any questions on arrays in general, actually, because after this, we're going to move on to a new topic. All right. Well, I don't see any messages, public or private, and I don't hear anyone. So I will take a moment to go to the slides and talk about the next topic, which we have about 20 minutes for, which is good. And that is the idea of code flow. So far, all the programs that we've written execute in the same way. They start at the first line of code that you write, they do that. They go to the second line of code that you write, they do that. third, fourth, fifth. They just run down your program top to bottom. It's always the same. Every time you hit that run button, it'll always run the same thing, right? Now we want to expand our programs so that we have the ability to kind of have different paths to take. So our program should now have forks in the road. Sometimes it'll go left, sometimes it'll go right, and that allows our code to be more flexible, allows our code to do different things depending on what it needs to do, right? And so that's the idea of code flow, having multiple paths for your program to execute. Right now, if we go back to our Eclipse, right, there's only one flow. It starts here, goes to the second line, third line, fourth line, and so on. It just goes top to bottom. But we want the ability to kind of jump around a little bit, run some code sometimes, but don't run it other times, right? And so how do we do that? One way to do that is if statements. And before that, even just like a quick example of when we'd need this. Well, if I have a program like, like this example is a little bit made up, but a lot of times you want to make decisions, and Java has a way of making decisions in code, and that is the condition statements. And these conditions go in something called a block. So it's like a block just means a group of code that all belongs together. And this block contains several things. It can contain if, else, and else if. So we'll just start with a couple. The most basic is just an if statement. Right, so you can use an if statement by itself. And what does an if statement do? It takes a condition, and depending on if that condition is true or false, it will either run or not run code. And there's several ways of creating if statements. Here are two examples. So the if statement, you literally just type if, then you have parentheses. Parentheses are required. And then you have your condition. I'll talk about this condition thing a little bit further later on. But you have some sort of condition. And then you can have two different forms. You can have it like this, where you just have your statement on the same line, or even on the next line. But this is called this is a one-line if statement. This, you can only have one line inside of this if. If you want multiple lines of code to be conditionally run, then you need curly braces. And curly braces designate a block of code. So a block of code all run together. And so here is if you only care about one line of code in your if statement. Here, if you have multiple lines of code, you want to use a curly brace. In my examples, I'm pretty much going to exclusively use this one. Even if sometimes I could replace it with this, I just prefer to always have the curly braces. I think it makes it look a little bit less confusing, in my opinion. We'll get to this later, but let's look at conditions. Conditions should sound familiar when I said they're either true or false. And that's because we kind of covered them already. Conditions are just Boolean expressions. So Booleans, if you remember, is a data type that's either true or false, right? Only two values for a Boolean. A Boolean expression is just something that evaluates to a Boolean. So you can have an expression, you can evaluate it, and the output of that evaluation is either true or false. And so expressions are created using comparison operators and combined with our Boolean operators that we've seen before. So for example, the comparison operators, you can have your equals, your not equals, your less than, greater than, and less than or equal to, greater than or equal to. And our Boolean operators were our ands, the ors, the nots, and there's this exclusive OR, but we're not really going to cover that much. And so a Boolean expression is just something that contains one or more of these symbols. So for example, here we're just creating a couple of variables. This is not too important, but all of these are Boolean expressions. So x greater than y, that's a Boolean expression because we can evaluate this, right? We can figure out what this is equal to. Well, in this case, x is 4, y is 6. So is 4 greater than 6? No. Here, b is going to be false, right? So this is a Boolean expression, and the evaluation of this is false, at least in this case. If we change the values of x and y, then the value of this would also change. So notice the expression does not change, but the value of it can change depending on the inputs in the expression. Really quickly, maybe let's take a moment and look at this one. X greater than y, or maybe let's look at this one, a little bit more interesting. X less than y or y less than z. So can anyone tell me if we evaluate it with these values for x, y, and z, is this going to be true or is this going to be false? Okay. So I see some answers, some direct messages, some in public. Yeah, the answer to this is going to be true. And the reason for this is, why is this true? Well, x is 4, y is 6, z is 0. So let's look backwards. Y less than z. Y is 6, z is 0. So is 6 less than 0? No, it's not. But we're using an OR statement. So not all is lost. If you remember, OR only cares that one of the sides is true, right? It doesn't require both sides being true. So we know the right-hand side is false. So that's kind of a problem, but let's look at the left-hand side. The left-hand side is saying x less than y. Well, x is 4, y is 6. Is 4 less than 6? Yes, it is. This side is true. Well, we have an OR statement, and one of the sides is true. So this whole thing evaluates to true. Right? Again, this is a Boolean expression. It contains comparison operators. It contains these Boolean operators, and it evaluates to a true or false value. Right? So this is a Boolean expression, and this is what goes right here. This is the condition that we're talking about. Because you can, maybe the naming should make sense, right? You can have a condition x less than y. If this is true, we want to run some code. If it's not true, then we want to do something else maybe, or we just ignore it completely, right? And so let's look at this in Eclipse. I'm going to keep this, I'm just going to comment it out. But let's look at if statements, and then maybe I'll do the code above. So let's put some space. And so I can say, let's create the variables. X is 4. This is just from the slides, there's 3 random variables. And we can say if x is less than y, system.out.println. Yeah. Right. Oh, I'm used to Python. I need double quotes. Right. And so if we run this code, you'll notice it prints out yeah. And that's because, yes, 4 is less than 6. If we update these values though, what if I change this to an 8? Well, if we run our code, now nothing happens, right? And that's because, well, this condition is false. So whatever is inside the if statement is not run at all, right? It's ignored, it's skipped over. So here's the first example of, we have code right here to print out yay, but it's not run, right? It's in our code, it's there. But when we run our code, it's not executed. And that's because of the code flow. The flow of the code in this case is it starts up here, creates our 3 variables, it checks the if statement, and because the if statement, the condition is false, it skips over everything inside this block, right? And then if there was more code below, it would run that. But in our case, there is no more code, so our program just stops. So that's the most basic condition or a conditional statement. It's the if statement. Any questions about this? How this if statement, how it works, or how to write it, how to use it, any of those? So that's an if statement. Now what I want to do is talk about two other statements. The first one will be the else statement. So the else statement always goes after an if, or you can only have an else statement if you already had an if statement. So here we say if x is less than y, we do this stuff. The else is basically the opposite case. If this isn't true, then we'll do whatever's inside the else. So maybe instead of printing yay, I'll say boo, right? And so here, it prints out boo. And again, that's because x is 8, y is 6. This is not true. So it skips over this. And then the else says, okay, well, this stuff above wasn't true, so I'm just going to do this instead. Right? So if this, run this line, else, if it wasn't true, then do this stuff. Right? So that's an if else. If else oftentimes goes along with each other. You can have an if by itself, but you can't have an else by itself. You can only have an else with an if. If you notice, this else is pretty broad in its scope, right? It didn't really matter anything. It just said, if the stuff above wasn't true, I'm going to run this. No questions asked. What if you want to have a conditional else statement? So you want an else statement, but you don't always want it to be run. You have another condition for it to check before it actually runs it. And that is something you can also have. That's something called an else if statement. It's kind of a combination of else and if. So else if basically says, if the stuff above me was not true, but I match this new condition, then I'm going to do whatever's in my block. Right? And so the else if goes between the if and the else. So I'm going to create a couple lines. I can say else if, and then have my code block. And then, oops. So you kind of need these together. So we do it like that. And something's wrong. Oh, something's wrong here. Let me go back here. Oh, I know what's wrong. I need a condition. So maybe y is less than z. All right. Else if y is less than z, just out dot print line. Right. So maybe let's update. All right. Okay. So here, does anyone want to guess what will be run if I hit the play button? Which message is going to be printed out? Yay, meh, or boo? And so you can look at the variables, you can look at the conditions. What is going to be run? Oh, oops. I stopped my share screen for a second. Get it back. So Cadence says boo. I see another direct message says boo. Any other people? So another answer for boo. Yep, boo is the overwhelming answer, and that is the correct answer. So if we run this, it's kind of a trick question. We put this else if, but our output is still bool. And the reason for this is, well, the else if is not like the else. The else doesn't really care about anything. As long as you reach that point, you will run the code inside of it. Right? The else if, though, is a bit pickier. It needs to meet this other condition, right? It's different from the first one. It needs to meet this condition for the code to be run, right? And here our condition is y less than z. Well, 6 is not less than 0. So this is not true. We're not going to run it. Right? I think a more interesting question is, well, what if we change these values? So x less than y, let's make that true, right? Let's have x be 2 and y be 4. So this statement is true. And y less than z, well, let's make this also true. Let's do 6, right? So in this case, I've changed my value so that x is less than y. This is true. This is also true. So make your predictions on what will be run. You don't have to put it in chat. You can just keep it to yourself. But in 3 seconds, I'm going to run it. And we can see it prints out yay, which a couple of people input in chat, which is good. So important thing about these conditionals is that it will only do one of them, right? So in this case, both of these conditions are true. However, it will always do the first one, right? And this is important. Sometimes the ordering of your statements will matter because of this. But yeah, that's all I wanted to point out. It checks them in order, top to bottom. Here, the if statement, this condition is true. So it will print out yay. And then, very importantly, all of this kind of goes along with each other. And so what happens is, because the if statement the condition was met, it does the code inside the block, and then it skips everything else. It doesn't bother checking the else if statement. It doesn't go to the else statement. It just skips over them. And if I put something here, like a done message, you'll see that it prints out yay, and then it skips down here and prints out done. Right? So only one of these is ever run. The last thing I want to point out before ending class today is that you can have multiple else if statements, right? So you can have a lot of different conditions. Right? I don't know what's going to be run, but you can have something like this, right? And maybe they'll have different statements. Here, it's still going to print out yay because it doesn't really matter what this is. This one's always going to be met. But as besides the case, you can have as many else ifs as you want. So to go over this, you can have an if statement is always the first one in a conditional system. You always have the if. You can just have the if you want. You don't need an else if. You don't need an else. Doesn't matter. After the if, you can have as many else ifs as you want. You can have 0, you can have 1, you can have 10 of them. Right? You can have 100 of them. Doesn't matter. Finally, at the end, you have your else. And this is kind of your like last ditch effort. None of the things above worked. And so here's what I'm just going to do instead. It's the catch-all, right? And so this always goes at the end, and you only have one of them, which makes sense because it's not picking at all. As long as it gets there, it always runs. So it doesn't make sense to have multiple of them or put them in the middle, right? So it always goes at the end, and you have at most one. You don't need it. You don't need an else, but if you do, it has to be at the end, and it has to be 1. All right, so I'm at 7. That's all I wanted to cover for conditionals. I'll go over the homework. I'll post instructions on the homework on Classroom. I'll also post the slides, even though I know we didn't spend much time on them. But before we end class, does anyone have any questions for me? Happy to answer anything about conditionals, or if you had any questions about arrays, 2D arrays that came up, happy to answer them now as well. Well, if not, we are at time.